Hi everyone. The question says an attacker at the base of a castle wall 3.75 meters high throws a rock straight up with a speed 8.40 meters per second from a height of 1.50 meters above the ground. If you read that entire sentence, you should have a picture, a figure in your head. We have the castle wall equal to 3.75 meters, and we have a person standing 1.5 meters above the ground. Perhaps he has a ladder or something, and this is his initial height 1.5 meters above the ground. So think about these positions when you are solving the problem. You have your ground, x equal to 0. You have the person, this attacker, standing at 1.5 meters. And finally, you have the maximum height of the castle, 3.75 meters. And we are given the next information. What is that equal to? 8.40 meters per second. That is the initial velocity of some rock, right? Yes, this guy is trying to take over the castle with a rock. How smart. So now the question is asking you, will the rock reach the top of the wall? Will the rock reach the top of the wall? I'm gonna show you one way. If you have your other way, that's also fine. But there's an indirect way of determining whether the stone is gonna reach the top of the wall. What should you do? How should you approach the problem? Use the following equation I'm going to give to you. Write down the initial velocity, right? And calculate how far it will take the object to reach the maximum height. Maximum height. Because why? At the maximum height, we know the velocity is going to be 0, right? And the moment you insert your initial velocity, right, you have your acceleration, and you can solve for the maximum height the object reaches. The maximum height the object reaches. So carry on your plugging in, and you end up having, in my case, delta x equal to 3.6 meters. So what does this mean? If you were to throw a stone with an initial velocity of 8.40, the maximum height it would reach is 3.6 meters. Now let's go back to our drawing. This person is standing 1.5 meters above the ground already, and the maximum height the stone can reach is 3.60 meters. So is the stone gonna reach the top of the castle, guys? You have 3.75, but you have 3.60 here. However, he's already standing 1.5 meters above the ground. So when you do your subtraction, when you determine this height here, it's going to be 3.75 minus 1.50, which is smaller than 3.60 meters. What does that mean? The stone is going to be able to reach the top of the castle and even continue further in space. So will the rock reach the wall? Instead of focusing on the wall itself, determine the maximum height the stone can reach. Next question. If so, what is its speed at the top? If the stone can reach the top of the castle, what is its speed? Where do you begin? You begin by writing the initial velocity that has not changed, right? Followed by your acceleration that hasn't changed either. Now the question is asking you, what is the speed at the top? So now you must determine the delta x, right? What is the delta x? The delta x is the distance between the top of the castle and wherever the person is standing. So that's going to be this length here, 3.75 minus 1.50. Take this displacement, plug it in, and you will determine what the final velocity is. Of course, I'm not going to do that. You have to do it, and you will see here my subtraction. This is my delta x. or if you want to call that delta y. Next one, does the change in speed of the downward moving rock agree with the magnitude of the speed of the change of the rock moving upward between the same elevations? The answer is no. Explain why. Just write something. I'm not going to grade that. On the day of the exam, I'm not even sure if this is an exam question, but if I were to give this to you on the exam, I would just put down A and B. I would not put down C or D. Okay? So this is the end of the problem. Let me zoom out.